Good morning, everyone, and welcome to our webinar on 3D printing welding fixtures. My name is Alexander Kreis. I'm a content engineer here at Markforged, and I'm joined by Marco Medecki, our marketing coordinator, who will be helping with questions later on. And on to our agenda for the day. I'll give a brief introduction of Markforged and our customers. I'll talk a little bit about the challenges that have to do with welding fixturing and how 3D printing can fit in to help resolve some of those challenges. And then I'll go on to describe some examples to showcase where the value in printing welding fixtures with Markforged printers lies and how 3D printing can help streamline that workflow. And then I'll open it up to some questions, and I'll help answer a couple of questions from the audience. All right, a little bit about Markforged. We were founded out of MIT in 2013, headquartered in Boston, Massachusetts. We shipped our first printer, the Mark I, about 3 years ago, and since then we've expanded and developed our product line and achieved profitability in Q1 of this year with 300% year-over-year growth. We come from a lot of different backgrounds. We have employees from MIT, Tullio, Cisco Meraki, Olin College, Enernoc, Sonos, and Bell Laboratories. And our products cover the full range of materials in 3D printing, from plastics to continuous composite reinforcement to metals. Today, we've shipped thousands of machines to customers worldwide, and our customers, ranging from small machine shops to international businesses, use our machines for high-strength, high-quality parts in a wide variety of applications, from tooling and fixturing to functional prototypes to end-use parts. We have a wide network of value-added resellers who provide support, maintenance, and training to our customers. Our products are trusted by industry leaders. Our customers span many verticals, including aerospace, automotive, healthcare, consumer products, manufacturing, and education. The companies listed here use our machines to create high-quality parts for real-world applications. So what we aim to do is to empower engineers to unlock the next 10x innovations in design and manufacturing. All right, so now let's talk a little bit about welding fixtures. So welding is frequently done on a welding table where parts are clamped down with a series of clamps, jigs, and alignment features. Often these fixture clamps and guides are general use tools for a variety of setups, and as a result, they can take a long time to set up and may not be suited for specific jobs. Now that's a bit about generic fixturing for welding. There's also specialized weld fixturing, for example, this bicycle welding jig here, where you can get custom or specialized fixtures to hold specific components in precise orientations. Now for something like a bicycle welding frame, it's a little bit more generic and modular, but for something more unique for a specific product on a product line, for example, these fixtures can be very costly because each part of the fixture needs to be designed, drawn up, sent out to a shop, and it may take a few weeks to get that part back from the shop, and depending upon the fixture complexity, could be expensive. So often custom fixturing requires a higher initial investment because each piece of a fixture needs to be machined and has long associated lead times. So as your welding operation gets more and more complicated, so does the fixturing, and this is where the real challenges lie, because for more complex 3D structures, using off-the-shelf fixturing can be challenging and unwieldy, and especially if you are in low-volume production, a custom fixture will ensure a more precise and higher quality welding job, but may not be achievable at that point. So where can 3D printing help? So in general, 3D printing can assist in many of the fixturing and setup needs required of welding by complementing existing welding tools and technologies with its own advantages. So I'm going to be covering in general the 3 benefits 3D printing can provide for welding, and later show specific use cases that exemplify these benefits. So first let's talk about precision. So in welding, a lot of the more standard off-the-shelf fixtures and clamps that you can get are not very precise. And there are a lot of places where imprecision can occur. It could be that your tubes aren't notched correctly, It could be that your fixture, like the one shown in this photo, has no precise indicators or measurements. So components can often be difficult to align, and this again gets more complex as you're building larger structures. Where 3D printing can fit in general with precision is by providing high precision and dimensionally stable fixtures that can keep and hold your welding tubes rigid during setup or during the welding operation. All right, now let's move on to setup and teardown. So by 3D printing custom welding fixtures, you can drastically reduce the setup time on your welding table. So again, each clamp on a setup and each alignment feature needs to be located, supported, and aligned every single time you're setting up a job for welding. And again, this only takes more time with each additional tube or clamp. So features on a custom fixture can make it very easy to drop in your part on your fixture and have it be precisely located and aligned. So the last overview that we'll cover is cost. So one of the huge benefits of Markforged printers is their ability to replace custom machined components, because the fiber reinforcement allows for the strength of metal at a fraction of the cost. So some of our customers have seen up to 95% cost reduction on printed versus externally machined parts. For custom fixturing, often for more complex welding operations, custom fixturing could be out of budget because you are spending a lot of time and money getting a very specific part machined for a specific welding operation. So by printing out your fixturing for welding, you can save costs and time by printing the fixtures instead of having them machined. So you can get your fixture at a fraction of the price, ready to put on the welding table next day, instead of having to wait 2 or 3 weeks for a custom machined component to come in. So now let's talk a little bit about some implementation examples. So one of the first things I'm going to talk about is just printed fixturing. So as I described earlier, complex structures with non-standard geometries are difficult to fixture, and traditional fixtures can make the process lengthy, but custom fixturing is costly. So printing fixtures is actually an affordable solution for tack welding steel, and this really can simplify a setup because it allows you to align and locate your pipes very, very easily. One of the reasons why this works is that our parts have a heat deflection temperature of about 150 degrees Celsius, and so for tack welding, where the heat is very concentrated, this is actually a feasible solution. As long as the fixture points are well out of the heat affected zone of the part, they can hold up. So here's a video showing a welder using one of our Markforged fixtures to weld this frame structure. All right, so as I mentioned, Markforged materials have a high heat deflection compared to other 3D printing plastics and can actually withstand the heat from tack welding. We were TIG welding steel tubing, and after the tack welding operation is complete, the part can be taken off the fixture, and the welding operation can be completed after the tacking is complete off the fixture. And one of the other benefits is that you can reinforce these parts with continuous strands of our composite fibers, like our fiberglass, and that will keep the fixture rigid and stable during the setup for welding, so that you're guaranteed that you're holding your components in the right place as you're setting up your fixturing. All right, so the next sort of application is custom risers and mounts. So it may be necessary to keep the frame that you're welding in a fixture during the entire welding job, and a lot of times standard welding fixtures do not guarantee a repeatable process. So for example, this clamp over here in the photo requires a lot of setup and moving around to get it to the right spot for an application like this. And again, with odd orientations like this, it increases the cost of machining and lead time because you're making this odd clamping part that needs to hold this pipe in a particular orientation. Things like this can also be printed, and one of the benefits is that it's possible to use custom printed risers and mounts throughout the welding job. So it's a cost-effective and an easy process. So what we have here in this photo is we have a custom printed clamp mount that is holding a part on at a 60-degree angle so that it can be welded at the joint. We have pressed in fixture supports that you can see supporting the beam and a clamp bolted into the fixture that holds that beam in place. So for standoffs or supports like this, going with a stainless steel fixture support or clamp as the point of contact will actually isolate the heat around the part if the heat reaches that area. What that means is that it won't really permeate into the part and you can continue with your welding operation. So for things like this, again, you don't have to deal with trying to precisely locate and align your tubes with modular fixtures. The setup time is minimized as each fixture is uniquely designed for its application. So in general, this reduces cost by eliminating the need for custom machined fixtures while increasing the quality of your final part because you know that your beam is in the right location, and by overall streamlining the setup process. All right, so the last application that I'm going to discuss is alignment jigs and check gauges. So often modular welding fixtures, as I mentioned before, are imprecise and can lead to alignment issues during or after welding, and it takes time to adjust these types of fixtures to achieve the results that you want. So in some cases you may tack your pipes together and you'll realize that after the entire thing is set up that you'll need to redo some of the welds if the parts aren't held or oriented correctly or in the wrong place. So even if you don't intend to use the printed fixture directly in the operation you're working with, maybe you're using more conductive or higher temperature materials, 3D printed parts can still be used as alignment jigs. So a printed jig will work together with a more modular clamp or fixture to ensure proper part alignment during setup. So this, again, decreases the setup time and allows welders to confirm that their setups are correct on the first try instead of maybe having to weld and then re-weld after realizing that their setup was imprecise. And furthermore, the jig can act as a quality assurance tool after the welding operation is complete to confirm the model specifications. So both before and after the process, you can use the fixture that you've designed to ensure that your part is meeting your quality standards. And again, this helps reduce setup time, minimizes job failures, and ensures that your end result is a high quality weld and it meets the standards that you want.